In this lesson, we'll go over linear equations, also known as first degree equations. The basic format of a linear equation is y equals some number times x plus some number. So the first thing to notice is that there's two variables. There's a y and there's an x. Okay, very important about linear equations is the reason why they're called first degree. And that's because the exponent for the x is 1 and also y is 1. So if we had something like y equals some number x squared plus some number dot dot dot, could be anything, could be number x plus a number or anything like this, doesn't really matter. Because there's a squared here, this is not a linear equation. The exponents have to be 1. Okay, and what we want to do with linear equations is actually solve for one of the variables. So we just want it to be some variable such as y equals everything else, whatever that everything else is. So for example, we had y plus 5 equals x minus 6. We want to get the y by itself. And we're going to do inverse operations, reverse PEMDAS, to get y by itself. Okay, don't worry about the fact that there's an x over here. This is just, a number minus another number. Doesn't matter. The only thing we're going to focus on is this y. So we want to get the y isolated. So this is y plus 5. So to get rid of the plus 5, you have to subtract 5 from both sides. So we're left with y on this side. And now on this side, when I subtract 5, I'm going to subtract it from this negative 6. Okay, we're going to combine like terms. So the number goes with the number. So we still have x. Now we have negative 6 minus negative 5. That's negative 11. So this would be our final answer, the equation y equals x minus 11. Let's look at another one. So we have 3 halves times x plus y equals 6. Alright, what we want to do here is actually get rid of this 3 halves. So we have 3 halves times x plus y equals 6. So again, this is x plus y, and remember we're solving for y, so we have x plus y. We would add those together first if this was order of operations, and then multiply by 3 halves. So the first thing we're going to do is get rid of the 3 halves, because that would be the last thing we do in regular PEMDAS. So to get rid of 3 halves, I'm just going to multiply it by the reciprocal. This way it cancels out perfectly. I'll do that on this side as well. Okay, I'm going to go over this real quick. The reason why I can multiply it by the reciprocal is because this is 3 halves times that. So we want to divide by 3 halves. But what's 3 halves divided by 3 halves? Well, you have to do keep, change, flip. It's really 3 halves times 2/3. So by multiplying by the reciprocal, I actually am dividing by 3 halves. Just a little side note as to why this works, why we're allowed to do that. But anyway, we're left with x plus y over here. Now here we have to multiply. Now maybe you want to put this over 1 so we can cross cancel. Becomes a 1, becomes a 2. Then we have 2 times 2 is 4 over 1 times 1, so we just have 4. Okay, now last step, we have x plus y equals 4. Okay, we want to get the y by itself, so we have to get rid of this x. So we're going to subtract it. So we have y equals. Okay, now we can have 4 minus x as the answer. But normally we're going to write the x term first. So let's just write this as negative x coming first. And then there's a plus sign in front of this 4 because it's positive. So negative x plus 4. So for first degree equations, we're going to have two variables, both of them raised to the first power, nothing greater than that. And we're going to solve for one of the variables. In most cases, we're going to solve for y.